In today's video, we're going to talk about systems again. Remember, systems consisted of two or more equations. So we're going to look at some that are already graphed for us, and we are going to look at some that we have to graph ourselves. So if you look at the directions, it says, look at the linear systems graphed. What are the solutions? If you remember from the last video, the solutions were the point where they intersected, or the point that made both equations true. But when you have a graph, you just look to see where they intersect. So in the first graph, I see those two lines and they intersect at the point 1, 1. So there's one solution because they intersect at one place. All right, let's look at example 2. So in example 2, I see a red line and a blue line, and I notice that they don't intersect. And it looks to me like they're parallel, right? That's what would make them not intersect ever. So since they're parallel and they're never going to intersect, there are no solutions. And we can write it like that, or don't forget you can use the symbol. Now just be careful with this because these will never intersect because they're parallel. So if I were to draw two lines, let's say there's one line, and let's say here's the other line. Well, those two lines don't intersect yet, but eventually they would intersect. So that wouldn't have no solution. That would eventually have a solution that you just can't see. So if that happens on a problem that you are working on an assignment, I've tried to make sure that they intersected on the graph that it provided or on a small enough graph. So if you see that happen, check your graph, check your slopes. It's possible that maybe one of your lines is going the wrong direction. So that would have a solution, you just can't see it. But in example 2 here, no solution because they would never intersect because they're parallel. All right, now in example 3, if you take a look, I've got the blue line, and then it looks like the red line is graphed right over the top of it. So that means these 2 points intersect everywhere, at every single point that you could possibly have, right? That when I draw the red line over the blue, it would intersect at every single point that it touches. So this one would have infinitely many solutions. All right, so when we have linear systems, so a system with two lines, we could have them intersect at one point, like example 1. They could never intersect because they're parallel, like in example 2, so there'd be no solutions. Or they could be one line graphed right on top of the other one, so they would intersect at every point, which would have infinitely many solutions. All right, so this says find the solution or solutions to the system's graph. So this time I have a few different options. So in example 4, notice this time I have a linear function and a quadratic function, so a line and a parabola. But I'm still looking for where they intersect. You just might have different kinds of answers. So in example 4, they intersect actually at 2 places, here and here. So we would have 2 solutions. So this one that's on the y-axis is 0, 3, because the x coordinate is 0, right? You didn't move right or left, you stayed there, and then you went up 3 for the y coordinate. And the other solution is 1, 2, 3, 4, 5 for the x coordinate. And then up 1, 2, 3, 4, 5, 6, 7, 8. So 5, 8. So there are 2 solutions, for example, 4. If I'm going to ask you to find the solutions of a system and they're not linear, then I will provide the graph for you. All right, so let's find the solutions to the system graphed in example 5. Well, I see 2 parabolas, and I see that they never intersect, and they're never going to. So there are no solutions again. All right, example 6, I see these 2 lines do intersect, and they intersect at 2, 5. So that is the solution. There's only one. So the number of solutions could vary on what kind of functions you have graphed and how they intersect, or if they even do intersect. All right, so let's practice graphing this system. So we're going to graph the system to find the solutions. So from the last video, if you remember, we're going to graph y equals 1/2 x minus 1 by finding the y-intercept first, which is this. So the y-intercept, or the b value, is -1. So on the y-axis, find -1. There it is. And then our slope is 1/2. Both of them are positive. So we're going to go up 1, right 2. And I need to do that as far as I can. And I need to go the opposite directions too, just in case they intersect over there. So I'm going down 1, left 2. And I draw my line. So now I need to draw the other one. And when I go to look at this equation, I notice, well, it doesn't seem to have everything. So if you notice, it only has a y value. So if you think way back, if linear equations only have a y value, then it is horizontal. So we're going to find where y is -3. So on the y-axis, 1, 2, 3, -3 is right here. And we're going to draw a horizontal line. And when I draw that horizontal line, the two lines did intersect at this point, which is the point -4, -3. So that is the solution. So solve the system by graphing. We graphed it. We found they intersected at the solution -4, -3. Now, if the second equation that I did in red, if it was x equals instead, remember that that would have been vertical. So if you have x equals a number, that would have been a vertical line. We didn't have that in this case, but just in case. So if we're going to graph it in our calculator, one of the equations was 1/2 x minus 1. The other one was y equals -3. And we can hit graph, and we can see they intersected. And again, from before, it might be hard to see exactly where they intersected, but we know it's for the x values between -3 and 6. And you might be able to change your calculator and zoom in a little bit, and you might be able to see it that way, but it looks like it's where x is -4. So if I go to my table and find where x is -4, there I notice the y values are both -3. So I know it was the point -4, -3. You can also do second trace, number 5 intersect, and then you can do left bound, right bound. Now this time my x's are not to the left of where they intersect, so I need to arrow over there so they are to the left of where they intersect. And then it says right bound, so I go move my arrows to the right of it and hit enter, and I do get at the bottom there intersection -4, -3. If you had a vertical line where it was x equals, notice when I hit the y equals button, there is no place for x equals. You cannot draw a vertical line using your calculator, so you would have to do that one by hand. All right, so for our last question here, solve the system by graphing. So we're going to graph one more, and we're going to see where they intersect. So on the first one, I notice my b value, or my y-intercept, is +2. So on the y-axis, put a dot at 2. And then my slope is the number in front of x. Well, there isn't one, so it's 1. And I need to make it a fraction, so I'm going to go up 1, right 1. And I keep going. And I'm going to go down 1, left 1 as well. And I'm going to keep going as far as I can. You may go as far as you can on your graph too. Draw your line. And now when I go to draw the other one, here's my y-intercept at -4. And I notice my slope is also 1, so 1 over 1. So I'm going to go up 1, right 1 again. And I keep going up 1, right 1 as far as I can, down 1, left 1. And I noticed that my lines did not intersect, because that's what I was looking for. So since they did not intersect, I needed to see, well, wait, are they parallel? Yeah, their slopes are the same, right? Their slopes are both 1. That means they're parallel. So this one would have no solutions. So no solutions for this graph, for this system. So again, when they are parallel and they never intersect, there are no solutions to the system.